Welcome back, children. Now after learning what a linear equation is, we proceed further with introduction to quadratic equation. So I hope my children have understood what exactly linear equation is, and the two types is what we have seen: linear equation in one variable and two variable. Now, if anybody can give me a general form of, we started over there also with general form of linear equation. If anybody can tell me what could be a quadratic equation. Okay. What is the general form of quadratic equation written as? The general form of quadratic equation written as ax square plus bx plus c. Ax square plus bx plus c equals to 0 is termed as a quadratic equation where a cannot be equal to 0. So we have a condition here also. As we had a condition in linear equation, we also have the same condition over here as well. So let's once again refresh it. What is the general form of quadratic equation? Any equation which is of the type of ax square plus bx plus c equals to 0, where a not equal to 0 is termed as a quadratic equation. Over there, why we were saying an equation to be a linear one? Because the highest degree was 1 of the variable. What is the highest degree of the variable here? The highest degree of the variable is 2. The highest degree of the variable is 2. That is the reason we say this is a quadratic equation. Quadratic means degree 2. Quadratic means degree 2. So whenever an expression has the highest degree 2, we term it as a quadratic equation. Finally, we summarize. Any equation which is in the form of ax square plus bx plus c equals to 0, where a not equal to 0 is termed as a quadratic equation. Now, sir, what is a then? A is nothing but again coefficient. Coefficient of what? Coefficient of x square. Coefficient of x square. Then what is b? B is also a coefficient, mind you. B is also a coefficient, but of x. And finally, what is c? C is any constant. What is c? C is any constant. We are right now understanding general form of quadratic equation in one variable. Mind you, our variable is only one. We have used only one variable. So this is quadratic equation using one variable. And the variable over here is nothing but x. We can have quadratic equation in two variables also, right? But as of now, we need to focus on what is the general definition of quadratic equation. Coming back, a and b are the coefficients of x square and x respectively, and c is any constant. Again, what values a, b and c can have? A, B and C can have any real values. A, B and C can have any real values. Let's summarize. Any expression which is in the form of, or any equation which is in the form of ax square plus bx plus c, ax square plus bx plus c equals to 0, where a not equal to 0 is termed as a quadratic equation. Now, there are many minds right now asking a question to themselves also and to me also. Sir, can B and C be 0? It is only one condition you have written. A cannot be equal to 0. Can B be 0? Can C be 0? Let's understand. So, I'm just writing it. A note. What if B equals to 0? When we have B equals to 0, this entire term will be 0. When we have b equals to 0, this entire term is 0. So what I'm left with? Then, can I say I'm left with ax square plus c equals to 0? Then I'm left with ax square plus c equals to 0. Children, still this is a quadratic equation. So we can have b 0, and if b equals to 0, then the expression turns out to be ax square plus c equals to 0. Still we say it's a quadratic equation. Why? As per the definition, the highest degree is 2. And children, this is a special type of quadratic equation. Such quadratic equations are termed as pure quadratic equation. Such type of quadratic equations are termed as pure quadratic equation. I'm just writing a shortcut of quadratic equation. Such are termed as pure quadratic equation. So say for example, if somebody has to say 4x square plus 16 is equals to 0, you can have minus 16 also, or for that matter one can say 4x square minus 16 equals to 0. Here c is negative, here c is negative, here c is positive. So each of them are nothing but pure quadratic equation. Finally, what if, sir, if C happens to be 0? If C happens to be 0. Children, if C happens to be 0, is this going to be 0? What I'm left with? I'm left with ax square plus bx equals to 0. Ax square plus bx equals to 0. Still it's a quadratic equation. Why? The highest degree is 2. Children, this is also a special type of quadratic equation. This is termed as ad-factored quadratic equation. This is termed as ad-factored quadratic equation. What is this termed as? Ad-factored quadratic equation. Say for example, 3x square plus 11x. 3x square plus 11x equals to 0. So, once again, ax square plus bx plus c equals to 0, where a not equal to 0 is a definition for a quadratic equation. What if b is 0? We get a pure equation, pure quadratic equation. What if c is 0? We get an ad-factored quadratic equation. I hope my children have understood what are the three types of quadratic equation we can have. This is the general definition or introduction, you can say, introduction to quadratic equation. We will solve much further. You will understand many more things as we proceed further and solve sums. You will be able to categorize from your side what equations are pure, what equations are ad-factored, and how to solve them. That's what we are going to see in the further slides.